Hello everyone, welcome to my channel C.S.E-Pathshala. We were studying about machine learning using Python 3, and in this tutorial we will study about simple arithmetic and rounding decimals. So if we talk about simple arithmetic, we can use arithmetic operators like plus, minus, multiplication, division directly between the NumPy arrays. But still there is an extension to use such kind of functionalities in NumPy that will take an array like objects, for example list, tuples, etc., and perform arithmetic conditionally. Okay, so what do I mean by arithmetic conditionally? It means that we can define conditions where the arithmetic operation should happen. Okay, so we will apply certainly methods or a function like add, subtract, multiplication, division to perform those operations which can be done with the help of operators. So in the previous tutorials we already seen about the basic arithmetic operations like addition, subtraction, multiplication and division. In this tutorial we will see some other arithmetic operations, like first one is the power. If we talk about power, the power function rises the values from the first array to the power of the values of the second array and then returns the results in the form of a new array. So let's consider a code where we need to raise the values in ARR1 to the power of the values in ARR2. So let's consider a code and implement it on Jupyter Notebook. Alright, so here it is. Import NumPy as NP ARR1 equal to np.array. So we are having a NumPy array with the elements like 10, 20, 30, 40, 50 and 60, and then we are having ARR2, that is np.array 3, 5, 6, 8, 2 and 33. It's a NumPy array actually. So new ARR, that means we are creating a new ARR which is being assigned as np.power ARR1 ARR2. Okay, so ARR1 to the power ARR2. Okay, and then we are printing its value. So let's save this code and run this code. Alright, so here it is. Here's the output. That means 10 to the power 3, 20 to the power 5, 30 to the power 6 and 40 to the power 8. So if it happens that the limit gets exceeded, so we are getting such kind of values which is not a reasonable one. But however, if we are having values like for example 4, or we are just having value like 5, or just make it as 6. So let's save this code again and run this code. So here it is. This is an output. Okay, so here we need to find the power of 33. Let's make it 3. So let's save this code again and here it is. Now here's the output, okay, which we are expecting. Alright, so now the next one is the remainder. If we talk about remainder, so both mod and the remainder functions return the remainder of the values in the first array corresponding to the values in the second array and returns the results in a new array. Okay, so how does it happen? That means we are having two methods here, that is mod and the remainder. Okay, so let's consider the first one, that is the remainder. So we are implementing this code on Jupyter Notebook. Okay, so import NumPy as NP ARR1. Again we are taking an array, okay, with the elements 10, 20, 30, 40, 50 and 60, and ARR2, that is 3, 7, 9, 8, 2 and 33. Okay, now we are performing mod operation. Okay, so new ARR equal to np.mod ARR1 comma ARR2. That means we will divide ARR1 element with the element of ARR2, and whatever be the remainder we are getting, we are assigning it to the new array. Okay, and then we are printing it. So let's save this code and run this code. So here it is. Now how the output has came? So 10 divided by 3, the remainder will be 1 obviously. 7 divided by 20, the remainder will be 6. Okay, and similarly if we divide 30 by 9, the remainder will be 3 and so on. Alright, so we can get the same result if we use the remainder function also. Okay, so let's consider one more code. Previously we did use mod function, now we are using the remainder function. Okay, so here it is. Import NumPy as NP. We are taking the same set of array, that is ARR1 and ARR2 with the same values. Okay, now only the changes, new ARR equal to np.remainder instead of mod. Okay, so np.remainder ARR1 comma ARR2, it will perform the same task as we did in mod. and then we are printing the value. Okay, so let's save this code and run this code. So here it is, we are getting the same output. Alright, now the next arithmetic operation is, that is the quotient and the mod. Okay, so the div mod function return both the quotient and the mod. Okay, so we are having div mod function for both the operations, and it return values in two arrays actually. The first array contains the quotient and another array represents the mod. Okay, so let's consider a code and then we will understand how it actually works. Okay, so here it is. Import NumPy as NP. Again we are taking the same array. Okay, and that is ARR1 and then ARR2. Okay, both these arrays are same as we did took previously. Then we are performing div mod. Okay, then it's written as new ARR equal to np.div mod ARR1 and ARR2, and the result will be in the form of two arrays. Okay, as it has been said. That means the first array contains a quotient and the second array will be containing the mod. Okay, so let's save this code and run this code. So here it is. So we got two arrays. The first array is your dividend. Okay, so 10 divided by 3, your dividend is 3 and the remainder is 1. Okay, that means the mod of the remainder is 1. And then 20 divided by 7. So obviously the dividend is 2 and the remainder is 6 and so on. Okay, fine. Now the next thing is absolute values. So if we talk about the absolute values, both absolute and ABS functions do the same absolute operation element wise, but we should also use absolute to avoid the confusion, because Python is also having an inbuilt function that is called as mat.abs. So here we are using absolute method or function. Okay, so let's consider a code and implement it. Alright, so here it is. Import NumPy as NP, ARR equal to np.array. Here we are having both negative and positive set of values or the integers. Then we are trying to find the absolute values of them, like new ARR equal to np.absolute ARR, and then we are printing it. Okay, so let's save this code and run this code. So here it is. The absolute value of -1 is 1 because we are just looking for the numerical value. -2 it's 2, 1 it will remain as 1, 2 it will remain as 2, 3 it will remain as 3, and -4 its absolute will be 4. Alright, now if we talk about rounding out the decimals, so this can be primarily done by rounding out decimals in NumPy with 5 different ways. So these are truncation, fix, rounding, floor, and Ceil. So let's consider first one, that is the truncation. In truncation, we will remove the decimals and return the float number closest to the 0. Okay, so here we use trunc and fix both the functions. Alright, so let's consider one code, then we will understand how it will produce an output if we use truncate or trunc function. Alright, so here it is. Import NumPy as NP, ARR equal to np.trunc for the truncation. We are taking two values here, that is -3.1666 and 3.667. Okay, we are truncating these values and then we are printing the value of array. So let's save this code and run this code. So here it is. So the truncation value for -3.166 is -3, and for 3.667 it's 3. Okay, this is how we truncate these values. Fine. Or we can say that we can fix this value. So fixing can be done like this. Let's consider one more code, and instead of truncate or trunc you use fix. Okay, so import NumPy as NP, ARR equal to np.fix. Again we are taking the same set of values, -3.1666 and 3.6667, and then we are printing it. That means we are fixing the values. So let's save this code and run this code. Again we got the same set of output. Okay, now actually we want to truncate or we want to end the values possibly. So here the truncation of these values are respectively -3 and 3. Okay, now if you want to round off the values, so for that the around function is used, which increments the preceding digit or decimal by 1. That means if we want to round off one decimal point of 3.1666 and 6, it will be round off to 3.2. Okay, so let's consider a code and then you will understand how round off is being performed. Okay, so here it is. Now import numpy as np arr equal to np dot around 3.1666, 2. That means 2 decimal places we want to perform the rounding operation of this number, and then we are printing it. So let's save this code and run this code. Alright, so here it is, 3.17. Okay, it's been rounded off. Okay, now the next thing is floor. The floor function round offs decimal to nearest lowest integer. For example, 3.166, the nearest lowest integer is 3 to it. Okay, so let's consider a code and then you will understand how it works. So here it is. Okay, so import numpy as np arr equal to np dot floor minus 3.1666 and 3.6667. Okay, then we are performing the floor operations on them. So let's save this code and run this code. So here it is, minus 4, obviously it's the nearest integer to minus 3.1666, and 3 is being considered as the nearest integer to nearest lowest integer to 3.6667. Okay, now if you want to calculate the Ceil, before that there is a note that the floor function returns the float, unlike the trunc function who returns only integer values. Okay, in the truncation we also took the lowest integer values, but as it's been told that it will give an output in the form of integer. However, in case of floor, we are returning float values also. Okay, now the next one is Ceil. If you talk about Ceil, the Ceil function round off decimal to nearest upper integer. Okay, so it's an inverse of floor. Okay, so for example, Ceil of 3.166, it's 4. Okay, so let's consider a code and then we'll check how it works. Okay, so here it is. Import numpy as np arr equal to np dot ceil minus 3.1666, 3.6667, and then we are printing it. So the Ceil values of these are, let's save this code and run this code. So here it is. The Ceil value of minus 3.1666 is minus 3 because it is on higher cutoff. Okay, and 3.6667, that will be 4. Again, it's a higher cutoff. Okay, so these are the values which are greater than these numbers respectively. And previously in floor, we are getting the lower values. Okay, so that's all about simple arithmetic and rounding decimals. Okay, we will come up with more exciting tutorials. Thanks for watching. Kindly do subscribe to my channel.